Okay, in this video I want to talk about the distributive property. It's often called the distributive property of multiplication to addition, which, takes forever to say and is a mouthful. So if you just want to call it the distributive property, that's fine. That's what I call it. And let's just look at this problem right here. 5 times 3 plus 4. Okay. Well, the order of operations tells us that the first thing we do is add what's in the parentheses and then multiply it by the 5. So 3 plus 4 is 7, so we have 5 times 7, right? And that's going to be 35. Alright, so 5 times 3 plus 4 is 35. But what if we were to do it a little bit differently? What if we were going to say 5 times 3 plus 4 can be rewritten as 5 times 3 plus 5 times 4. And what's 5 times 3? Well, that's 15. So we've got 15 plus 5 times 4 is 20. And that's also going to be 35. Wow, it works. That's interesting. But, of course, that doesn't prove anything. Let's try it with some other numbers, see if this is just a coincidence or not. Let's take 7 times 4 plus 2, and let's see what that gives us. Alright, 4 plus 2 is 6, 7 times 6 is 42, so we've got 42. Now let's try rewriting this as 7 times 4 plus 7 times 2. Alright, 7 times 4 is 28, 7 times 2 is 14, so we've got 28 plus 14, which is also 42. Okay, so it worked twice for us. Of course, that still doesn't prove anything, but we should start to wonder now. Alright, let's take 6 times 5 minus 3. Here I'm going to use a negative, and let's see what that is. Alright, 5 minus 3 is 2, so 6 times 2 is 12. 6, and we're going to rewrite that as 6 times 5 minus 6 times 3. Or alternatively, we could rewrite that as 6 times 5 plus 6 times negative 3. Now, let's see what these give us. Okay, 6 times 5 is 30. 6 times 3 is 18, so we have 30 minus 18. Hey, that's 12. Alright, so let's see if this way worked. 6 times 5 is 30. 6 times negative 3 is negative 18. So we've got 30 plus negative 18. Hey, that's also 12. Wow, so this seems to be working no matter how we do it. What is this property that we're using? Why is it that this keeps working? This property is called the distributive property. And we can write it formally as A times B plus C can be rewritten as A times B plus A times C. Alright, so that's the kind of the formal definition of the distributive property. But let's look at how it works with dimes for a minute to see if we can prove this property. Okay, so what operation do I have here? Well, I've got 5 dimes coming this way, and then I've got 4 dimes going across. So what I have is 4 times 5. Alright, now, of course, 5 can be rewritten as 3 times 2, or 3 plus 2, right? So you could say I have 4 times 3 plus 2. Now let's try out the distributive property here, and let me just move these down a little bit. So I'll move them down here, and now, without changing anything, I didn't even rearrange them really, I just moved these down a little lower, and now I have 4 times 3 right here, and then I have 4 times 2 right here. So that is 4 times 3 plus 4 times 2. And of course, obviously they're the same number of dimes, right? Nothing changed. So there you can see right there that 4 times 3 is plus 4 times 2 is the same as 4 times 3 plus 2. Let me do something else now. 5 can also be rewritten as 4 plus 1, right? So I have 4 times 4 plus 1. Well, let's see if I can use my distributive property here again. I've got 4 times 4 plus 1, or 5, And that can be rewritten as 4 times 4 plus 4 times 1. So I've got 4 down here and then 16 up here. It's exactly the same thing. So 4 times 4 plus 4 times 1. Alright, so that's just kind of a visual depiction of the distributive property, and how really, when you do the distributive property, if you think of multiplication this way, all you're really doing is taking a certain number of these dimes and just moving them down a little bit. That's all you're doing. Alright, here's another thing that's important to know about the distributive property. Right here I have 6 times 3, that's 18, right? Well, I can split this up into, say, 2 times 3 plus 4 times 3. That's going to be 6 plus 12, which is also 18, right? But I can split it up in more ways than that. I can split it up, in fact, as 2 times 3 plus 3 times 3 plus 1 times 3. So I've got 6 plus 9 plus 3. That's also 18. So the distributive property doesn't just work with 2 numbers. It works with as many numbers as you want. So if I have 5 times 8 plus 6 plus negative 4, right? We can do it with negative numbers too, right? Plus 2. Alright, well, 8 plus 6 is 14, minus 4 is 10, plus 2 is 12, so it's 5 times 12, which is 60, right? But I can rewrite that as 5 times 8 plus 5 times 6 plus 5 times negative 4 plus 5 times 2. And what that's going to give me is 8 times 5 is 40. 6 times 5 is 30. 5 times negative 4 is 20. Or sorry, 5 times negative 4 is negative 20. And then 5 times 2 is 10. So we've got 40 plus 30 is 70, minus 20 is 50, plus 10 is 60. So we get exactly the same result. So you can see that this property works even if there are more than just 2 numbers in there. Alright, now one more thing I want to talk to you, and then this video will be done, is distributing negatives. Let's say I'm given 5 minus the quantity x squared plus 3x minus 2. Okay, you might get something like this in algebra. Well, how can we use the distributive property to rewrite what we have here? We can rewrite this expression, first of all, by saying 5 plus negative 1 times this whole thing, right? Because when we have negative, because subtracting is the same as adding a negative, right? So we've got negative 1 times x squared plus 3x minus 2. And then we can take this negative 1, and we can go ahead and apply the distributive properties of that, and say this is negative 1 times x squared plus negative 1 times, here I'll put a parentheses there too, negative 1 times 3x plus, I'm out of room, plus negative 1 times 2. Alright, and we've got 5 plus this whole thing. Okay, so now negative 1 times x squared is negative x squared. Negative 1 times 3x is negative 3x. And then negative 1 times negative 2 is going to be positive 2. So we've got plus 2. Alright, so and then we can just take this 5 here, and we don't have to worry about the parentheses anymore. Alright, so what happened here? We had x squared plus 3x minus 2, and now we have negative x squared minus 3x plus 2. What happened here was we just switched the sign of everything inside this expression right here. So what was a positive became a negative, positive, negative, and then what was negative became a positive. That's what happens when you distribute a negative. And it's just the same as the distributive property, you're just the number outside of the parentheses is something that can be rewritten as negative 1, right? And then we can add these together and get negative x squared minus 3x plus 7 if we just add these 5 and 2 together. Alright, so that's all about the distributive property. Thanks for watching.